Okay, hello everyone. It's Melissa again, your math teacher, and a couple of questions were asked over email about the section 1.7, the polynomial and rational inequalities. And the question that was asked was basically, do I always have to set these things to 0? And then there's a time when, you have to there's a time when you have an inequality portion of it, and there's a time when you have an equality portion of it, and sort of some confusion around that. So I want to just take a couple of examples here and show you what this looks like and sort of the process. You can see what's going on. So if we take this problem, 6x squared plus 11x and greater than or equal to 7. And if we solve this, and in your book or online it should say solve using the test point method. Okay, so if we're going to use the test point method, the first thing that we're always going to do is try and set this inequality either greater than or less than 0. So we want everything on one side and then everything else with just 0 on the right hand side. So I'm going to bring this 7 over by subtraction. So I'm going to have 6x squared plus the 11x minus the 7 greater than or equal to 0. Okay? All right. So now what I'm going to do is I actually am going to introduce an equality into this, but I'm only introducing an equality in here in order to find the points that I'm going to use on my number line to test with for this test point method. Okay, so I'm actually going to take this expression and set it equal to 0, but I'm knowing that, I'm still working with an inequality. I'm just doing this, I'm taking a little bit of liberty right here to find these points where I zero out. Okay, so if I factor this, it's going to factor into 3x and 2x and 7 and 1, it looks like, positive and negative. Okay. So if we solve that, then we're setting, 3x plus 7 to 0, 2x minus 1 to 0, and just solving these, you get x is negative 7/3 and x is 1/2. Okay, now these two values right here are not solutions. What they are is they're points on your number line where this is possibly going to transition from positive regions to negative regions. So if I take a look at a number line, say this is negative 7/3 and this is 1/2, and 0 is between them. And what I want to do is I want to choose some points that are in each of these regions, but not actually on the point. Okay, so for instance, negative 7/3, that's negative 2 and negative 2 and 1/3. Yeah, negative 2 and 1/3. And then a half. So I want to actually choose maybe like a negative 3 over here. And then in between here I'm going to choose 0. And then over here I'm going to choose 1. So just choose some values in those regions. If I look at these actual points, because I'm dealing with greater than or equal to, I can actually include these points in my solution. So I'm going to put closed dots on them. Okay, now what I'm doing to check this negative 3 is I'm actually just plugging it back into this. Either you can actually plug it back into this, or you can actually plug it back into the factored form if that's easier for you. And what you want to do is you want to decide, when I plug negative 3 in, what does this expression become? Does it become positive or negative? Okay. So if I plug a negative 3 in, I see that in this factorization right here, I get negative 9 plus 7. That would give me a negative 2. So that's negative. Negative 3 minus 1 is also negative. If I take a negative times a negative, in this region, it's going to end up being positive. Okay. If I take 0 and plug it in, and I can see from right here, if I took 0 and plug it in, this goes away, that goes away, and I'm left with a negative 7. So in this region, my expression is going to be negative. And if I take a 1 and plug it in, if I plug in 1 right here, I get 3 plus 7, that's 10, so that's positive. Take a 1 and plug it in there, I get 2 minus 1, which is 1, which is positive. Positive times positive would give me a positive, so I'm positive in this region. Okay, now you have to go back and take a look at what it is that you're looking at This says greater than or equal to 0, so I'm looking for all of the values that are going to give me this expression being greater than or equal to 0. Okay, greater than or equal to 0 means positive values. That's what this means right here. So we are looking for the positive regions. Well, you can see right here that that's actually going to be from negative infinity to the negative 7/3. We're going to include the negative 7/3 because of the equal sign here. And then we're unioning that with 1/2 out to positive infinity. Okay, so that hopefully clarifies that you are using an equal sign to find these numbers. But when you go back and you evaluate this, you're actually sticking it back into the inequality and, you know, evaluating it from there. Okay, I think we have enough time. Let's try quickly one more. I have to keep these videos to 10 minutes. Let's try this one. X minus 1 over x minus 2 greater than 3. Okay, so with the rational inequalities, you're doing the same basic thing. You have to bring this over and set it to 0, and then you're actually going to take the numerator and the denominator and set to 0, okay, to find those partition points. So if I subtract this, x minus 1 over x minus 2 minus 3 greater than 0, and I need to actually get a common denominator here between these two fractions. So I'm going to multiply this 3 by x minus 2. So it's going to become x minus 2 in the top and x minus 2 in the bottom. Okay, I need to take the negative 3 and distribute, so this becomes x minus 1 minus 3x and then plus 6 all over x minus 2. All right, and now what I need to do, collect like terms in the top. And so I get a negative 2x plus 5 over x minus 2, and then greater than 0. Okay, so what I'm going to do is I'm going to find partition points by setting the top to 0 and the bottom to 0, and then dividing up my number line again, just like we did before. So if I take a negative 2x plus 5 to 0, you know, negative 2x equals a negative 5, so x is positive 5/2. X minus 2, when I set that to 0, I get x equals 2. Now it's important for us to remember, regardless of what this sign is right here, you cannot include 2 in this problem. And that's because 2 in the bottom is going to give you a 0, and 0 in a denominator is undefined. Okay, so that's something you need to be aware of in these problems, regardless of whether this is including 0 or not. You don't include 0 in the bottom. Okay, so this, if we divide up our number line again, it's going to look like our 2 and our 5/2 is 2.5. And if I just choose some values, I'll choose 0 here, and 2 and 2.5. So I actually have to choose 2 1/4 here. And then I'll choose 3 over here. Just choose something between them. Okay, I'm not including either of these values, so I'll have open circles. All right, so if I choose 0 and plug it in here, I see that I'm going to have something positive over something negative. So this region is going to be negative. Okay, I guess I'll put that down here. You can see it a little better. And then if I take 2 1/4 and plug it in, 2 1/4 times 2 is going to be a little less than 5. So it'll be positive in the top and positive in the bottom. So that'll be positive. And then if I take 3 and plug it in, negative 2 times 3 is negative 6 plus 5. So that's a negative 1 in the top. It'll be negative in the top, positive in the bottom. So it's going to be negative in the bottom. Okay, I'm looking once again for something greater than 0. That means I'm looking for positive values. The positive values here are from 2, and I'm not including 2, out to 5/2, and I'm not including 5/2. So it would look like that for interval notation.